Welcome to the Quadratic Forms video tutorial. The following examples will show you how to obtain the quadratic form, how to obtain the matrix quadratic form, and how to transform a given quadratic form into a form with no cross-product terms. Example 1. Let x be represented by the following vector. Obtain the quadratic form for the given matrix A. And notice that over here, x to the exponent t is the transpose of the vector x. To obtain the quadratic form, we want to compute x transpose multiplied by A multiplied by x. Let us begin by constructing matrix A. Step 1. Control and drag the equation A from the question. So to do this, we want to select our equation A, hold down the control key, and drag it into our table. Step 2. Open the context menu and select Assign Name. And now we have assigned this matrix to the variable A. And then let us construct vector x. Step 1. Control and drag the equation x from the question. So we want to select our equation x, hold down the control key, and drag it into our table. Step 2. Open the context menu. So we right-click, and then we want to select Assign Name. And now we have assigned this vector to the variable x. To obtain our quadratic form, we want to compute x transpose multiplied by A multiplied by x. Step 1. We want to type x to the exponent %t, and the exponent %t represents taking the transpose of our vector x, multiplied by A multiplied by x. Step 2. Press the Enter key. Step 3. Open the context menu and select Expand. And here we have obtained our quadratic form for the matrix A. This concludes example 1. Example 2. If x is a vector in R3, find the matrix of the given quadratic form. To find the matrix of quadratic form, you want to find the Hessian matrix of our quadratic form divided by 2. Step 1. Control and drag the expression for the quadratic form. So we want to select our expression for the quadratic form, hold down the control key, and drag it into our table. Step 2. Select the quadratic form and type /2. So we want to select the quadratic form and press the / key on our keyboard, and then enter 2. Step 3. Open the context menu, select Apply a Command. And then in the Apply the Command field, we want to enter vector, calculus, open square bracket, Hessian, and close square bracket. And then in the Append the Arguments field, we want to enter open square bracket, x, comma, y, comma, z, and close square bracket. By doing this, we are finding the Hessian matrix of our quadratic form divided by 2. Now press the OK button. And here we have our matrix of quadratic form. This concludes example 2. Example 3. Make a change of variable that transforms the given quadratic form into a quadratic form with no cross-product terms. Let us begin by going to Tools, Load Package, and then Linear Algebra. Now we want to find A, which is the matrix of quadratic form. Step 1. Choose the assigned function symbol from the expression palette. You will find the expression palette on the left-hand side over here, and you want to click the assigned function symbol. Step 2. Replace f with q. Since f is already selected, we want to just replace it with q. Step 3. Replace AB with XY. If you press the tab key, this selects A, and we want to replace it with X, and if you press the tab key once more, this selects B, and we want to replace it with Y. Step 4. Replace Z with the expression for the quadratic form. If we press the tab key, this selects Z, and we want to get rid of it, and then we want to control and drag the expression for the quadratic form. So we select the expression for the quadratic form from our question, hold down the control key, and drag it into our equation. Step 5. Press the Enter key. Step 6. We want to type q open bracket x comma y close bracket and then divided by 2. Step 7. Open the context menu and select Apply a Command. Step 8. In the Apply the Command field, we want to enter vector, calculus, open square bracket, Hessian, close square bracket. And in the append the arguments field, we want to enter open square bracket x, comma, y, close square bracket. By doing this, we are finding the Hessian matrix of our quadratic form divided by 2. A Hessian matrix is a square matrix whose entries are the second partial derivatives of our function. Now click OK. Step 9. Open the context menu, select Assign to a Name, and we want to enter A. Now click OK. And here we have our matrix of quadratic form and have assigned it to the variable A. Now we want to orthogonally diagonalize A. We do this by first finding the eigenpairs of A. Step 1. We want to type in A and press the Enter key. Step 2. Open the context menu, go down to Eigenvalues, and then Eigenvectors. Step 3. Open the context menu once more, go down to Select Element, and click 2. Step 4. Open the context menu, select Assign to a Name, and enter R. Now click OK. And the columns of our matrix R are the eigenvectors of A. Now let us normalize the first eigenvector of A. Step 1. Type R and press the Enter key. Step 2. Open the context menu, go down to Select Elements, and then Restrict Columns. Then type in 1 and check Strip Dimension. We do this because we want to select the first column of our matrix R, which is our first eigenvector. Now click OK. Step 3. Open the context menu, go down to Normalize, and then select Euclidean. Step 4. Open the context menu, select Assign to a Name, and enter P1. Now click OK. Now here we have our first normalized eigenvector and have assigned it to the variable P1. Now let us normalize the second eigenvector of A. Step 1. We want to type R and press the Enter key. Step 2. Open the context menu, go down to Select Elements, and then click Restrict Columns. Then we want to enter 2 and check Strip Dimension. We do this because we want the second column of our matrix R, which is our second eigenvector. Now click OK. Step 3. Open the context menu, select Normalize, and then Euclidean. Step 4. Open the context menu, select Assign to a Name, and enter P2. Now click OK. And here we have our normalized second eigenvector and have assigned it to the variable P2. Now let us construct orthogonal matrix P and diagonal matrix D. Step 1. Type P equals matrix, open bracket, open square bracket, P1, comma, P2, close square bracket, close bracket, and press the Enter key. Step 2. We want to type D equals P to the exponent percent T, which represents P transpose, space A, space P, and press the Enter key. So here we have our matrix P, whose columns are the normalized eigenvectors of A, and we have our diagonal matrix D, which is computed by P transpose multiplied by A multiplied by P. Now let us construct vectors U and X. Step 1. We want to type U equals left arrow U comma V right arrow, and press the Enter key. We do this because we want our new quadratic form to be in terms of U and V. Step 2. Type X equals P space U, and press the Enter key. And here we have our vector X, which is computed by matrix P multiplied by vector U. Finally, let us display our new quadratic form. Step 1. We want to type in Q open bracket X open square bracket 1 close square bracket, comma, X open square bracket 2 close square bracket, close bracket. This represents the first entry in our vector X, and this represents the second entry in our vector X. By executing this, we are substituting for X and Y in our quadratic form the entries of our vector X. Now press the Enter key. Step 2. Open the context menu and select Expand. And here we have our new quadratic form. Notice that there are no cross product terms. This concludes example 3. Thank you for watching the Quadratic Forms video tutorial.